Okay, we're almost through the list, so I think we should start to stay in time. Welcome everybody, good afternoon to this session on looking at data, what the data can tell us. It's a collaboration of Dash together with BCN's Nothing But the Truth. We will have a short introduction of Dash and then we'll continue the presentation of this afternoon. If you look at this graph, this is Dash. My name is Peter van Ooijen, by the way. I'm the coordinator of the machine learning lab of Dash, which is also one of the things that we do as Dash, running the machine learning lab. But we also run projects, so either projects that are delivered to us by researchers or projects that we run ourselves. We work on community building concerning data science within the UMCG. Also trying to get that community a little bit larger than just the UMCG. So also look at companies, etc., that we try to involve also in the projects that we have ongoing. We're an incubator for collaborations. We are supporting funding opportunities. So we either apply for funding on data science ourselves, or we help people out to apply for the part of data science in their research. So, for example, collaborate on work packages that concern artificial intelligence within projects that are written by another department. And the machine learning lab, we look at the needs assessment. So what does the UMCG, what do the people working at the UMCG need? Not only physically, what do they need in hardware and software, etc., but also in education and in training that we can give. So this the webinars that we provide is part of that education that we do based on the needs that we hear from different people working within the UMCG. Education is, as I said, these webinars by Dash, but also the short classes that we have online. If you want to know more about that kind of things, send us an email at dash@umcg.nl, and then we can give you links to get to the educational materials, and also you will be kept up to date of new events that are coming up. And communication is also part of the work that we do. So for today, we're in the Collaborate environment. A lot of you will already know it, but please put your microphones on mute to avoid any noise that might happen in the background. If you want to ask a question today to the presenter, please either raise your hand and wait for your turn, so we'll watch the list of people that raise their hands, and there might be a possibility to do questions in between. If not, then we'll collect them to the end. Or type your questions in the chat box. When you type it there, we'll also pick it up later on. We might give you the word then to explain a bit more about your question. But in the end, we will go through those questions. If time runs out, then the questions will be kept and can be answered later on. This webinar is being recorded, so it will also be available to listen to and to watch later on after this session has finished. So you can also inform people that could not attend today that the recording is online, so they can still listen and watch the webinar of today. So with that said, I would like to give the word now to Robert Schoevers, who on behalf of Nothing But the Truth will be the moderator for this session. Robert, the floor is yours.
Yes, thank you very much, Peter. Hello, everybody. My name is Robert Schoevers. I'm from the psychiatry department at the UMCG, and I'm also head of the Behavioral Cognitive Neuroscience Research School, which is an inter-faculty research school, mostly in Groningen, but we also collaborate with Twente University. And we had the brilliant idea to organize a live conference in last October, so this October, on the theme of truth, truth within science and truth coming from science and entering into society. Of course, there's one overwhelming truth that dictates a lot of our lives at this moment, which also dictated that our conference will not be a live conference, but it will be an online conference, and we moved the live conference to next year. But together with other parties, we had the idea to organize a number of webinars, and we're quite happy with this collaboration with Dash, and with the fact that Casper Albers will present his talk, which we think fits beautifully into our theme. So what is our theme? The first part of our theme is trust and truth, so truth and trust within science. As you all know, there's a whole debate on what drives scientific output, what drives careers of scientists. Are these perverse or stimulating triggers? What drives science, and can this be improved? And this concerns both the way individual researchers cope with the stress of the system, but we also want to focus on what are the best ways to deliver the best kind of science. So how can we get as close as much to the real truth? And this is only one part of the puzzle, because as you all know, once science delivers facts, then society has its own goals, its own motives, and as you see on the slide, there are certain people in this world who have sort of 100% score of using facts only for their own benefit. But somewhere between Trump and 100% truthfulness is where science policy integration takes place. And in our conference, we also want to shed light on what does this mean for you as a researcher. How does it? What kind of? How can you present your data in order to have the maximum? So to deliver the message in such a way that it's understandable for people, and that the risk of abuse, which does sometimes happen, is not too big. So the second theme is science policy integration. And in our conference, we have a number of people that you see here on the list. And as the conference moved to next year, so the physical conference, given that Corona will allow us in November next year. So we have a number of very interesting speakers who will present or who will actually be present. However, the first kickoff of this endeavor is Professor Casper Albers. He's professor in applied statistics and data visualization at the Faculty of Behavioral and Social Sciences. His main research lines include psychological dynamic models versus one-time measurements, and the other aspect that he involves much of his time in is how to improve statistical practice within social sciences. And both research lines basically meet in the field of data visualization. And Casper is also somebody who is very active in society in discussing the translation of and the interpretation of scientific findings. And his lecture will focus on how we present this and what is the consequence of that. So Casper, I'm very happy to that you're here, and I gladly give the floor to you. Thank you.
Thank you, Robert, and thank you very much for the invitation to be here and speak to you all. So let me first share my screen with you. Yeah, there we are. So indeed, I'm going to talk about data visualization practices, and two main messages will probably be how can you spot a flawed data visualization, and also how can you improve your own data visualizations. And I've tried to come up with examples from various different backgrounds, so it's not only social science data or medical data, but as broad as possible. So for starters, why would people be interested in visualization of data? Well, there are four main lines, and I think the first three are quite well known. So it's a good way to explore your data contents, especially nowadays when data sets become larger and larger. You simply cannot look at your Excel screen or SPSS screen anymore and see all your data. There's simply too much. You can use it to reveal data structures. You can use visualizations to validate statistical assumptions by making box plots or QQ plots. So those three things are pretty well known, but you can also use your visualization in a smart way to enhance the story that you try to tell, so as a science communication tool. And I think the fourth part is less well known, so I want to focus mostly on that. And data visualization is something which isn't very recent. We've been thinking about that for over a century. And a very common, well-known example of data visualization is the Anscombe Quartet. It's from, well, almost 50 years ago. And what he did is he came with 4 data sets. You can see them on the screen here. And all 4 data sets have summary statistics in common, in the sense that the mean of X, the mean of Y, the standard deviation of X, the standard deviation of Y, and the correlation between X and Y is the same. So if I would give you this data set with a table of summary statistics and say this is my predicted regression line, it would be exactly the same for all 4. But as you can clearly see, all 4 plots are fundamentally different. This looks like a good context, the top left. Over here there's a clear nonlinear pattern. Here there's a strange outlier in vertical direction, and here there's a strange outlier in horizontal direction. So looking at the data can tell you stuff that simply looking at some data summary statistics cannot. So I think in that sense, data visualization is already helpful. Yes, thanks for mentioning. I think it's now hidden. And this was a statistician who made this data visualization, but data visualization is being done by everyone. So this is another famous example made by the American President Donald Trump last year, when he was in between one of his impeachment processes. He came up with this map on Twitter, and he said, well, try to impeach this. And there was no legend to this map, but basically the red areas are areas where people voted Republican, and the blue areas were areas where people voted Democrat. And the message from this picture is immediately clear. The picture is telling you, well, almost the entire country is red, so everyone is voting for Trump and no one likes the other guy. That's kind of the message behind this. But of course, this isn't the complete story, and we've seen this type of visualization before, so I think most of us know it. But of course, if you look at where do the people live in the United States, there's this whole area over here which got a lot of beautiful mountains and deserts and nature, but not too many people. And in the end, it's people that elect a president and not mountains. So then people came up with this picture where they said, well, we make red dots and blue dots for each county, and the size of the dots is proportional to the number of people living there. And then suddenly the message is much more nuanced. Looking at this, you would say, well, red and blue kind of keep each other in balance. So this was replied to by one of the Democratic senators as a message of saying, well, the visualization that Trump just showed is completely nonsense. But the stupid thing is, this visualization also is nonsense, because in the US, it's not people that get to elect the president, it's states. So in a certain state you need to have the majority, and then I think there are 1 or 2 states with different rules, but in all the other states the candidate with most votes get all the votes. So if you look at a state-like picture, it would look like this picture on the left. So red states are Trump states and the gray states are the Hillary Clinton states. The picture on the left still is a bit strange because it's a geographical map of the US, but then again you've got all these states over here with barely people living in them, and other states like these ones with many people living in them, even though the state is smaller. So what they did on the right was kind of stretch the map in a smart way to make the size of each state proportional to the vote. So something like this would actually be the best way to demonstrate this type of voting behavior. The drawback obviously being that you don't even realize anymore that this is actually a map of the United States, but it is in line with the data. Another thing I want to say is you can really use anything to visualize your data. So this is from a TikTok movie by some economist called Humphrey, and he uses rice to demonstrate visualized data. So he came up with a movie where he showed, well, if 1 grain of rice is indicative of $100,000 of wealth, then these grains of rice, if you have so many, 10 of them, you're a millionaire. If you have this, you're a billionaire. And then he wanted to show how extremely wealthy Jeff Bezos, the head of Amazon, is by saying, well, he got 122 billion US dollars. And by showing it by grains of rice, you can really make it clear how incomprehensible wealthy 122 billion dollars is. Whereas if you would just write down the figure, everyone would say, well, billion sounds like a lot, so he must be rich, but you cannot really pinpoint how rich, and this type of visualization really helps with that. So those were a few examples. And what is data visualization? And data visualization, it's basically a way to convert your data into visual information. And you do it by targeting preattentive properties. What they are, I'll come back to that in a few minutes. And it's actually kind of a combination between science, skill, and art. So those 3 fields come together in the area of data visualization. And there are many ways to visualize data. And a study I really like, or it's actually a blog post, it's one by Ortiz. He came up with a very minimal data set with only 2 numbers, the numbers 37 and 75. And suppose you have those 2 numbers, you can already visualize that in many different ways. For instance, you can just write down the numbers themselves. That's already putting ink on paper or ink on your screen. So it is visualization. And you can do it with kind of the numbers we recognize or in a different script. Or you can keep a tally. That's all different ways of writing down numbers. You can make a graph, but then of course you can say, should I include 0 or not in my vertical axis? Should I shade the area beneath the graph? And all these 3 graphs really give a different indication of the data, even though the data themselves are the same. You can do with shaded lines. So the 75 has more shaded lines than the 37. You can just count blocks or icons or whatever. Stacked lines, colors with a different color palette saying this is 0, this is 100, and everything in between. Also it has a numerical value, etc. So there are many different ways to visualize data, and the question of course is, what is the way we want to do with our data? Sometimes data visualizations are really bad, and just to give 2 examples, you especially see those examples in, for instance, news programs on TV or newspapers. These are both graphs from the corona pandemic. This one on the left, if you look at the data, all the numbers are in there, the number of new cases per day. But the strange thing here, and I don't know if the font is readable on the on each of your screens, But the vertical axis, so the y-axis, goes from 30 to 60 to 90, so in steps of 30. But then suddenly it goes from 90 to 10 to 100, so a step of only 10, etc. So there they tweak the vertical axis in a very strange way. If you look at the picture on the right, that's just a very strange picture where we've got some numbers over here, and then this is a larger number, but you actually go down, and this is the smallest number, but it's in between other values. So this is just a mistake somewhere, and we don't know what happened. Those kind of mistakes are easy to recognize, but not always, because what people do, especially in newspapers, television programs, etc., is realize that most people don't take the time to really read and understand a graph. And where you can really see that happening is the next graph. This is a graph of the number of gun deaths in Florida, so the number of people killed by firearms from the 1990s up to a couple of years ago. And the first thing you see from this graph, if you look at it, is it seems to be slowly going up. And then in 2005, something happened. They enacted a certain law, and then bam, it went down again. And if you just spend a couple of seconds looking at this graph, you think, okay, it's a good thing that the government in Florida enacted the law because the number of gun deaths went down. Only if you really spend time looking at the graph, you realize that the vertical axis has been reversed. 0 is at the top, and the more deaths there are, the lower you are. So you start with a lot of deaths, 873. It slowly goes down until 2005. And then you got the stand your ground law, which basically says that if someone is standing on your ground, so in your front garden or anything, you're allowed to shoot the person without even asking them to leave first. And obviously that does result in more killings. So if you would visualize the figure in the way you normally would, you would do so by flipping the vertical axis, and you see that it immediately looks quite a bit different. So these are quite nasty tweaks of your visualization in order to make people believe something that's actually not in the data. Another example, and this is from one of the reports of our own university. A couple of years ago, in one of the yearly reports of the graduate schools, they said, well, what is the nationalizations of all the students that come to Groningen for one of our summer schools? And they came up with this pie diagram saying, well, there's a large chunk of Dutch people, quite a large bit of German people, because Germany, of course, is not too far away. And then we've got South Korea, America, Tanzania, etc., and a large chunk of other. And this is quite a misleading graph because it's a 3D pie diagram. And the bit here at the bottom, it's almost as if that's shoved into your face, and the bit at the back there is zoomed out. So if you would simply rotate this graph a bit, you could also make it look like this. And now it's the same proportion, but suddenly because the Dutch group is in front, it looks to be much more. And if you would count the number of pixels on this visualization that belong to the slice of the pie that belongs to the Dutch students, it would be over 50% of the pixels, even though about 25% of the students actually were Dutch. So something which is much better to do if you want to make a pie chart, keep it two-dimensional. And also, of course, all those nationalizations, there were over 100 different nationalities. You cannot show 100 different slices. So simply chunk them into categories that make sense. So something like this, we've got Dutch students, we've got European students from other countries than the Netherlands, people from Asia, people from America, and then everything else. So this is Latin America, Africa, Australia. This graph or visualization makes sense, and the two ones before actually don't. One of the topics that people often discuss when talking about data visualization is, should the vertical axis, the y-axis, start at 0? Yes or no? So this is a famous visualization from Fox News some 8 years ago saying, well, Obama was president back then, and the tax rate was 35% of the time, and he was going to make some tax cuts for the rich expire, and then the tax would inflate from 35 to 39%. And this graph over here makes it seem as if it's really a massive increase in tax percentage. Whereas if you include zero, you can actually see, well, there is an increase, but it's a much more moderate increase than this picture would suggest. So things like this make you think, okay, always include zero. It's actually slightly more nuanced than that, because suppose you want to talk about global warming and how the average temperature at the planet is increasing. You can make a picture like this, 1900 up to now, and you go on the vertical axis from 15 to 17 degrees, and then you can clearly see an increase. Whereas if you would include zero, the information you want to show actually turns out to be almost a straight line. You cannot really see the increase anymore. And on top of that, this zero also is just some kind of subjective choice, because why would you put the zero at 0 degrees Celsius? You could also do it at 0 degrees Fahrenheit and be somewhere down here, or even 0 degrees Kelvin, which would be way further down. So in some scales there isn't really a zero, and then it also doesn't make sense to include a zero. So it's interesting to think about, okay, when should you include a zero, but also does it really matter? So a recent study I did with Jonica Smeets and Jannetje Driesen, we looked at a situation where we presented participants at random with either the graph on the left or the graph on the right, which had to do with the number of blue beaks in Denmark in recent years. And the blue beak, that's a type of bird which we made up, and we gave them a story, but as you can see, both graphs, they are the same except for the vertical axis. So in both, you can see there's an increase in the number of blue beaks over the years. And we had almost 300 participants. We asked them, okay, guess the percentage of increase, and people did better with the graph on the left than the graph on the right. In the graph on the right, as you would assume, people do tend to over-exaggerate or overestimate the increase percentage. We also looked at whether framing had or context had an effect. So we looked at two different narratives. In one narrative, we said, well, the blue beak is a domestic bird in Denmark, and it's kind of being threatened by this specific type of vulture coming in from Russia and eating bluebird eggs. And the other narrative was actually that the bluebird was this predator bird coming in to eat up all the native birds in Denmark. But we found out that actually the framing, so that's the pictures on the left or right, didn't really have an effect. So it's really good to include zero, but don't include the context doesn't seem to matter too much. This vertical axis not only sometimes have a zero, which you can say should we include that in the graph, but also another value, for instance, 1. So here again some COVID graphs. The death rate varied by age, health, and sex, and the graph on the left was shown on the BBC website, saying, well, the older you are, the more at risk you are of, well, basically dying from COVID once you catch it. And here the question was also, well, here axis runs from 0% to 15%, but you can also, and that's what's being done on the right, let the axis go from 0% to 100%. The benefit there is that you immediately see, well, even the group most at risk, still the vast majority does survive COVID, which isn't immediately clear here. An obvious drawback here is that all these small percentages over here, you cannot even see them because they are only 1 or 2 pixels wide. So it's difficult to really come up with a single advice how to do it. One advice, what you can do, especially in online presentations where you basically have enough space to do anything you want, is show both versions, because both of them add something to the other. Of course, in printed media or printed articles, you have to make choices. But in online work, you have the space to do everything, and that can really help to increase the understanding. Going to a different topic now is bar charts. Bar charts are also very common. So pictures like the one on the left, we see all the time where you have a treatment group and a control group, and you have a mean value with some kind of standard error bar around it, and you can interpret. The problem, of course, is those bars, they only show the mean value, and the standard error bar shows something about the spread around the mean value. But then we've got these 4 different visualizations on the right, and all 4 of them collapse into the same set of bar charts. So they all have the same means, the same standard deviations, yet they are fundamentally different in the sense this one, for instance, both groups are actually the same, except for this strange outlier. And if you look at the bar chart, you would say that the white chart really is better than the black chart. Over here, there seems to be an issue with a very small sample size for the second group. So you can really include more information by showing individual observations rather than only summary statistics. And also, if you look at formal tests to check for differences, these 2 groups, they are significantly different, whereas, for instance, these 2 groups are not. So it really also matters. It's not only a matter of presentation, it's also a matter of the conclusions you can draw from your data. So you really can do more than just make a box plot. You can show your raw data. That's what I did on the previous slide. You can also do it like they do it here, but the problem with showing the raw data is that's becoming really difficult to interpret if you have too many observations. So if you have a large data set, 1,000 participants or more, you don't see much with all the individual dots, but then you can make some kind of filing plot, which is kind of a smoothed version of an histogram, which already tells you more than just the box plots do. Because all these G, so G is 7 different data sets in the picture on the left, they all collapse into the same box plot. So box plots really don't tell you much. They tell you the value of the median and of the quantiles, and that's almost it. And those filing plots, sometimes also called pirate plots, they already give more information. At the start, I mentioned preattentive properties, that you try to include those in good data visualization. Preattentive properties, it's a term coming from the Gestalt psychology, and a preattentive visual property, that's something which is processed in your spatial memory without requiring some kind of conscious action. So that's basically something which you can see, notice, and recognize without having to put effort in. And that's really useful to put those into your graph because they are intuitive to use. They don't take effort, they don't take any skill. So that's also something. It doesn't matter whether you're a statistician or really know nothing about numbers, you can see that difference and interpret it. So visual preattentive properties, there's a number of them. It's, for instance, color, form, movement, and spatial placement. Those are the 4 main ones with respect to data visualization. And if we first think about color, what we see over here, if we look at the top graph first, it's just a visualization of some letters. And suppose I find it important for the reader to quickly spot where the letter C is because you write my name with the letter C and that's a nice letter. I can use color. You can immediately see, because they are red, there's a C over here, over there, and over there. I could ask you the same with the letter B, but that's much more difficult to see because B is one of the many blue letters and you really have to put in effort. So this is also where the storytelling comes in. If the message you want to give in your paper is, okay, this letter C is important, or this type of illness is important, or this treatment is important, then you can use color to highlight that one and make the reader immediately recognize what is important in your study. You don't really have to use a different color. That's what you see in the second picture. It's all the same color blue, but some are more bright than others. It works in the same way. If you want to use colors, a few general tips that are easy to use common heuristics. For instance, we all know traffic lights, and then we know green is good, you can continue, or red is you have to stop. So if you have positive and negative information, make the positive stuff green, the negative stuff red. Keep in mind that many people still print out papers, etc. in black and white. Not all colors work. Don't use this rainbow palette because it simply has too many colors, and also why would yellow be halfway blue and red? That there's no intuitive heuristic for that yellow is halfway blue and red. It's much better just to move from, for instance, blue over here slightly into red or a different color. And also don't use too many colors. If we go back to this picture, this worked in finding the C's because it was the only distinct color. If you would use 26 different colors for all the 26 letters of the alphabet, of course the value of doing this is lost. Another tip is not everyone can see all colors, so there are different types of color blindness. And if you don't have any color blindness, you can recognize the number in this circle on the right. And if you have kind of normal vision, you see a rainbow palette over here. And here you see how people with certain types of color blindness see those different colors. So for instance, this red color and this green color by people with the deuteranopy or whatever it is, they actually see it as the same color, so they don't see a difference between red and green. So do keep that in mind. Going to the next preattentive property, which is form and spatial position. So form and position simply has to do with something like orientation, so all kind of lines vertical except for one diagonal one, or one being shorter than the others, or one being thicker than the others. That's all something which immediately makes sure that your eyes focus on the thing standing out. You can make things larger or more curved, less curved, have stuff grouped together, a different shape. All these kind of things help you to immediately recognize a certain something in your data. And that's the storytelling part. You can use those properties to guide the viewer to the interesting points in your data. So the message you want to tell drives the design. So you can also not say, if I do a certain study, so a clinical randomized controlled trial with 2 groups, and we want to know whether treatment is improving the condition of the patients, you cannot say a priori, okay, then you have to use this visualization, because it really depends on the story you want to tell with your data. So suppose we have 9 graphs over here, and those graphs could be maybe stock markets of different products or something like that. And then you see 3 out of 9 are colored in blue and the other 6 in red. And that's a direct way to make 2 groups out of them. Everyone immediately sees, well, there are 2 groups here, a red one and a blue one. And of course, the distinction here is that the blue lines, they seem to be declining, and the red ones seem to be increasing. So if that's the message you want to tell, some products have a stock price that increase, others have one that decline. You want to use this color coding. If the message would be different, for instance, some stocks have a price which is really high, others have a price which is really low, you would use a different coding scheme. Another way is, suppose this is some kind of time series with sales per month or whatever. Something which you can do to immediately get people's attention at the right place is say, well, I want them to show what was the month with the most sales and the month with the fewest sales. Simply make those 2 bars a different color, and also put a clear, easy to read label there. So the maximum is here and the minimum is there. It also works. Another example, this paper all had to do with stock prices, but of course you can generalize this to all kinds of contexts. The stock price of a product was like this, and it's a gray line with over here a blue period and over here a red period. And the reason you use different colors here is that the blue period was a period of relative stability. The stock price didn't really change much, whereas the red period was a period of real uncertainty. It went down and it went up again, and it bounced all over the place. So again, you can use your colors to indicate all the differences. One of the founding fathers of data visualization, of modern data visualization, I have to say, is Edward Tufte. He wrote a book, The Visual Display of Quantitative Information, in 1983. And in that book, he laid out some principles of good data visualization and good graphical integrity. And of course, we're almost 4 decades later. The way we make graphics is really different. So back then, you really made them with pencils on paper and special types of paper. And now we just ask a computer to make the picture for us. But the ideas behind what is a good graph and what is a bad graph, they are still the same. So one of the key axioms almost that Tufte came up with was the representation of numbers as physically measured on the surface of the graph itself should be directly proportional to the numerical quantities measured. So one thing he really didn't like were these kind of 3D type of charts, whether it's a bar chart or a pie chart, because if you compare this picture to this picture, it's the same data, but over here, because you have this kind of background pixels, it turns out that the number of pixels in blue in this area and in that area is not proportional to the values on the vertical axis. And that was for the always requirement number one. The amount of ink you put in a value should be directly related to the value itself. So that's also a reason why you should always include 0 in your vertical axis. Another thing that Tufte said is always make sure that you have clear, detailed and thorough labeling, and as much as possible write your explanations on the graph itself, and label important events in the data. So labeling important events, we saw that a couple of slides ago where I said this is the maximum, this is the minimum. But you can also think about something like this. So these are sales figures in a supermarket or something, and you see there's a yellow line which you use, and then there's dairy, tea and coffee. That's all fine, but if you look at the order of the lines, yellow on top, orange at the bottom, it doesn't make sense to have your legend in this order, because there's no basic way in which you could order things. It might be different if this was some kind of ordinal or continuous variable, but it's not. It's not even on alphabetical order. So it doesn't make sense to say, well, the top one in the legend belongs to the third line, this one to the bottom line. So it makes much more sense to actually put this in the right order. And instead of putting it as a legend to the side of the graph, simply put the labels next to the line. There's no need for a legend if you can put the text in the graph. And again, that's something which works if you don't have too many different lines. If you do have too many different lines, you can't do that anymore. But this graph already is much more readable than the one on the left. Another principle of Tufte was the so-called lie factor. Yes, the question is, if there's not enough space next to the lines, would you recommend placing the legend on top of the graph? No, I would not. I would, in that case, if you really have too many lines, for instance, because you want to show 20 products, then maybe you have to say what product is important, for instance, coffee, and then only highlight the coffee line by making that, for instance, blue, and the 19 other products, you keep them in gray, and just in the text say, well, the coffee line is highlighted and the other ones are not. And then you can't see in the graph anymore for each individual product what is this, but that's not something you want to put in a graph. If you really want to have a table of 12 months, 20 different products, so 12 times 20 data points, you probably you shouldn't use a graph for that, but a table in an appendix or something. Tufte came up with the life factor, which again had to do with, for instance, not having this kind of 3D shading. And he said, well, the size of the effect in a graphic should be proportional to the size of the effect in the data. So if you compute this quotient, it should be close to 1. That's something which also happens outside the area of data visualization, but for instance, geographical visualization. We all know it's impossible to make a two-dimensional map of a three-dimensional world. And one of the consequences is that in one of the common visualization types, so this is how Google Maps does it, Greenland seems to be huge. And then there's this nice tool where you can actually select a country or an island or something and drag it to another area of the world and see how large it is if it would be over there. So in this picture, Greenland seems to be larger than the US, but if you drag it down over here, you see that it's actually roughly a third of the size of the US. And if you drag it down to the equator, it becomes the smallest it can be. And you can see that, for instance, Brazil is much larger than Greenland. This is an example outside of data visualization, but it also happens with data visualization, especially if people try to make funny or interesting types of data visualization. So this is a very old example having to do with the number of exports of cars to different countries. And they showed, okay, how does it develop for different countries, Indonesia, Morocco, Tunisia, and Algeria, in 3 subsequent years. And then you see, for instance, for Algeria, it went from 6646 to 11,610, indicated by this person becoming larger, larger, and larger. But of course, the problem is if a person almost doubles in length, it also doubles in width, so it actually becomes 2 times 2, 4 times as large if you count the number of pixels. So the life factor for this type of graph is 2, which is definitely not something you would want. One other principle that Tufte came up is if you make a graph, it should never quote data out of context. So this is an example from, if we look at the picture on the left, from one kind of report that a government agency or the police department or something in Connecticut brought out. They came up with this very simple figure. They said, well, we put in stricter law enforcement to combat traffic deaths. And in the year before we did that, there were 325 traffic deaths. And in the year after, it was about 280 casualties. And this figure is, of course, telling a very strong story. People died massively before we did something, and then we came up with a wonderful law, and then people stopped dying. One thing is that they were a bit seductive with the vertical axis. If you would include 0, it would already be a different story. But the thing that I want to pinpoint now is that they also took this data out of context. Because if you also look at the data of previous years and coming years, you can actually see in the years 1951 up to 54, all years before they came up with stricter law enforcement, the number of casualties actually was lower than in this year after stricter enforcement. And if you look at it in this context, suddenly the law enforcement doesn't seem to be as effective anymore. So always keep the context in mind. To also show a local example, this was a picture of traffic casualties per 100,000 people in the Netherlands. So it was quite large in the early 1970s, like in all European countries. And then roads became safer, cars became safer, we had traffic lights, seat belts, all these kind of things, and you see a very steady decline over the years. But what you can also see, if you would really zoom in here, is that it went up by about 1 or 2 pixels. So what you see in newspapers every year, because this is data you report every year, you can come up with headlines like the number of traffic casualties rises again. Maybe technically it's true. The year before it was 627, now it's 629. But if you look at the full graph, then basically the only correct headline would be number of traffic casualties is still pretty low, which is good news. The last principle of Tufte I want to mention is the one on the data to ink ratio. Tufte always says be really careful with the amount of ink you use in your graph. Just treat your ink as if it is gold and you have to pay for every pixel you put on the screen or every drop of ink you put on paper. Only use it if it is really necessary, and also only use it if you need it for the data. So above all else, show the data. Remove everything that's non-essential. And a context where this always works, or where this works really well, is traffic signs. Because of course with traffic signs you're driving past them with 80 kilometers per hour or whatever. You don't have the time to really stop and interpret the sign. You have to immediately see what is happening there. So if you look, for instance, at this sign, it's just saying there's a traffic light coming up. That's all the information you need. This sign is saying there's a bump in the road. It doesn't have to be a symmetrical bump like here. It could also be a couple of bumps. That's all non-essential. The only essential message is be careful, the road is bumpy. And the image is immediately showing you that. You can have the same thing in data visualization. So if you use Excel, and I think many of us use Excel quite a lot to simply look at data, and you ask for a visualization of your data, quite often you get something like this. This is one of the default pictures that Excel, I think I use Excel 2017, gives you. So again, it's sales figures, but it can also be number of patients or whatever data you want to show. And there's a lot of information going on here that you actually don't need. And quite often people simply think, oh, it's a feature. Let's click all the features, put it in there just because I can. But it's much better to take it out just because you can. For instance, let's start with the background. The background is shaded from almost white to blue-gray and then staying blue-gray. You can just take it out. You don't lose any information by taking it out, and the message already becomes clearer. In the next step, you can also say, well, the graph here, I show both dots for all the observations as the line. I don't need to do both, I can do just one of them. This is again showing the same with fewer information. And then another thing you can do is say, well, do we really need all these numbers on the vertical axis? If we know that it goes from 0 to 350,000, isn't that enough? Or even 300,000 because you don't exceed that. So in 3 steps we went from this picture to this picture. This picture uses much less ink, yet it still has all the information, all the statistical information that the original picture had. So that really is an improvement. In the last 2 slides, I want to say, what can we do now to make good graphs? So I've showed a number of examples where things didn't work as they should work, and also some of those rules by Tufte. One good tip is just start by making a sketch on pencil and paper. Don't start by pressing buttons in Stata or SPSS or R or whatever software you're using. Really just make a sketch, what do I want it to look like, and try out various alternatives. I'm not going to into software details a lot because of time, but also because we all use different software. One thing I want to mention is if you're SPSS, you're kind of doomed because it's almost impossible to make good graphics there. If you use Excel, you can really make some nice graphics, but the default graphics, like I showed on the previous slide, is not really nice. if you use programming languages like R or Python, you really can do everything you want, and then the number of options can be overwhelming. And one thing that can really help is use internet. There's this wonderful website, I look at this at least twice a week, chartmaker.visualizingdata.com, and it got a really large kind of database saying what kind of graph is there, for instance a bar chart, and all the software packages, and for all types of packages, all types of charts, common charts, but also quite exotic charts like a waterfall chart. Every circle you see here, if you click on it, you get examples and the demo code to see how it works. And quite often you can just copy paste that code for your own data and have a data set that works. And another tip is really just play around. Don't make a graph and think, okay, I'm done. But think about all the choices that you have. And websites like this can really help you to get more insight into good graphics. So thanks for your attention.
Thanks a lot, Casper, for a very interesting talk. I don't know if people have questions at this point. You can put them in the chat. While you're doing that, I have a question. Everybody thanks you. You were showing very clearly that my question is basically, is there some gray between objective, righteous presentation and presentation leaning towards a certain goal? Those rules, I think, are very relevant, but you also show that, and you started with, do data illustrate my story? Are they helpful to illustrate my message? So you sense subjective elements, and you sense also some kind of ethical consideration. How far should we go to stress certain differences in light of very righteous motives, for example?
Yeah, I think indeed you can use all these graphical properties to lead the reader to a certain line of thought, but of course also to mislead them into that direction. So it really has to do with the intentions you have on why do I make this type of visualization. And it's a bit like questionable research practices. Often when you do research, you do a zillion different things and you write your report, and then you don't report on all those zillion things because you simply don't have the space. And as long as you make defendable choices on what you report on and what you don't report on, and say, well, I report on this because this turned out to be really interesting, that's fine. But if you say, I actually omit that my competing product was actually selling better than mine because I want to claim that I'm the best, then of course you're cheating a bit. And similar things you can do with visualizations. You can use it to cheat, but you can also use it to lead. And it's not that there's a real clear distinction between the two. There's a gray area in between.
Okay, thank you very much. That was very clear. And I'm looking at the chat, and I think that there was a lot of praise for your talk, and so there was a lot of appreciation, and also it was very clear. So your data, the way you presented them, introduced very little unclarity, which I think is a very good point. Given that the time is also over, I would like to end this session and thank Casper very much, and thank Dash for the collaboration, and hope to see you all again in the Nothing But the Truth next webinar. Thank you very much, and have a good day.